Hi guys, so this episode is gonna be a little bit special. We're not gonna see a lot of code running, but we will examine something that is gonna be a little bit spoilery because it kind of spoils a little bit of what comes for next episode, which is concurrency. But since it's probably the best example of using Java interop that I have in the standard library, I guess we're gonna have to go with this. So this is a module for asynchronous concurrency. As of version 0.3.3, there are two different modules for doing concurrency. One is this one, the other one is about functional reactive programming, but which is based on the async module. So, well, the async module works by providing an abstraction called async, which basically works like promises in other programming languages, and it is all implemented in terms of tools that the Java platform already provides. And those tools, I need to be able to interact with them. So now we're gonna see some of the things that Lux offers in terms of Java interop. So for instance, I can import JVM classes and their members, including, for instance, methods such as static methods and normal virtual methods, such as this one. And this is a syntax that the JVM import macro uses. You give it the name of a class or an interface, and it can have parameters, such as this one, because some JVM class and interfaces are polymorphic. Or, well, not polymorphic. Polymorphism is something else in object-oriented programming. They are parameterized, like the java.util.list. And so this is syntax for importing methods. So the first thing can be a flag such as static, though it is optional. Then goes the name. Then this tuple here contains the names of any type variables associated with just the method. If that variable doesn't come from the class definition but from the method definition. The second tuple contains the Java classes and types of the arguments, which, by the way, you cannot just use any Lux type here. For referring to arguments, you can only use Java types. So here, it doesn't take any argument, but in this one here, it does. In this execute method of the executor class, it takes a runnable. And finally, you have the return value, and it can be any Java type: int, boolean, long, float, or it can be a class. It can have, if it's a class, it can have parameters. It can be void. And with that, what you're gonna get is that this macro is going to create a type that is going to be reflective of the class. So there will be a definition named runtime that will have a type that points to the Java runtime class. And for every method that you for every method that you import with this macro, you're gonna get a function that's gonna work this way. It will take as its first argument a tuple of all the arguments of the method, and as its second argument, it's going to take the object on which to operate. However, if it's a static method such as this one, it only takes a tuple. In this case, since it takes no arguments, it's going to take an empty tuple or unit. And here in available processors, it's going to take unit, and then it's going to take an instance of runtime. Here I'm importing the runnable class with nothing else. By the way, when you do these JVM imports, you only get what you specify, nothing else. So here in this thread class, I'm importing the constructors. The constructor is imported using new as the keyword instead of using the name of the class as would be, for instance, on Java. And since you always know in the constructor that you're gonna get an instance of the class, you don't have to specify a return value. Instead, you specify if there are any type variables associated with the constructor. and the arguments. You can also import enumerations if you're working with enumeration, and again, you only get what you import. So this class here has many options, but I'm only importing the milliseconds time unit enumeration. And yeah, so the way the functions are imported, it's really interesting, because you're actually, the way the names of the functions are gonna be is that, well, first of all, see this here, schedule, thread, pull, executor. This is not the Java class. This is a Lux definition. This is a Lux definition. This is a Lux variable. It just happens to have the same name as a class. This is a Lux variable, and the contents of this variable is a type data structure that contains information relating it to this class. Okay, that's how it works. And remember that in this class, we introduce the constructor here and this function here, this method. Well, now you can see how to use a constructor. Here, it's the name of the class, 2 columns, then the name, in this case, the word new, instead of something like constructor. We get the word new, which is our keyword for constructors, and then we have to give it an integer, an int here, and we get that int by getting this runtime. Doing the get runtime here, we have that from this method here that gives back a runtime, and then we get the available processors for that runtime, which gives us an int, and that's what we give to this schedule, thread, pull, executor, because it takes an int. Simple as that. And that way, we get an executor that has as many threads as there are processors, which is really nice. Here we are importing the toString method from objects. Also, by the way, when we do these imports, we're always gonna get a type that is gonna be just the short name of the class. So we're gonna get a type definition that's gonna be named object. It's gonna have this shape for the type, data t, and an empty list of arguments. That's how the type is going to look like, the type data structure. But if we want to have the long name of the type instead of the short name, we just have to pass this option that is named long. This is very useful, for instance, here when importing the java.util.list class, because the Lux standard library already comes with a list type. And if we use a short name, then we will have a collision, because unless you did not import the list type from the standard library, the compiler will think, hey, if you ever use the word list all by itself, I wouldn't know if you're referring to list from the Lux module or list from this JVM import. So by using this long option, we can avoid those kinds of ambiguities. However, the long option wouldn't just work for the type itself, it will also work for the prefixes of the functions. So we also have a java.util.list : add method, or add function here. And we can even look it up. And it is indeed the case. We get the add method, the get method, and the size methods. All those methods. Well, that's far, there's a little bit more to it for imports. But right now, this is more like a small introduction to JVM interop, because there's really a lot you can do. So besides that, we can also make here, you can check this out, we can make anonymous classes. We use it with the object macro. And for those of you who are familiar with Clojure, this is kind of like the proxy macro in Clojure, or the RayFi macro. For those of you who are more recent to Clojure and might be more familiar with RayFi. So you give it an optional superclass. In here, I didn't add it because this anonymous class will only extend interfaces. So you could have an optional superclass and then a tuple containing all of the interfaces that you're gonna be using. Then this tuple here will contain arguments to pass to the constructor of a superclass. Now, here, since I'm omitting the superclass, it really doesn't make much sense for me to add this. But, I guess I have to update the macro so it doesn't take it. It's kind of unnecessary, but right now you have to pass it. So this is the tuple that contains the list of arguments to pass to the constructor of the superclass. That's something you need to do if you are going to be making anonymous classes. And then comes the definitions of the methods, the method implementations. So in this particular case, I am overriding the run method from runnable, and I have to specify the class. I know it sounds kind of weird because when you override methods in Java, you don't need to specify the class, but you actually kind of have to when you compile things down. The Java compiler just tries to be clever to spare people from having to specify it themselves. But here on Lux, you actually have to specify, hey, I'm overriding a method from the runnable interface. The method is named run, and these are the type variables of this method. These are the arguments of this method. This is the return value, the return type, and this is the return value. So, by the way, it is important to say, what the return types translate into. So, for most types, it's pretty straightforward. For those of you who remember for those of you who saw the video on Lux data types, you already know that Lux ints are actually longs. So if this were a long, I could return any normal Lux integer, simple as that. So Java ints are not Lux ints, but there are simple functions for conversion whenever you need to use them. For converting back and forth between longs and ints and int and longs, and if you have a way to convert between a long and an int, you can use that for Lux ints. Void, though, transforms into unit as far as the Lux type system is concerned, and that's why we return unit here. Now, some of you might know. Now, you probably are not familiar with this exec macro here. Exec is actually something you're probably familiar with if you're already a Lisper, but you have seen it under different names. So if you are from Clojure, exec is the same as do, as the do macro or do forms in Clojure. It's just the same thing. The reason why it's called exec in Lux is mainly because I already used the word do for do notation for monads, but that's the only reason. But exec in Lux is the same as do in Clojure, which is the same as proc n in Common Lisp, if you are a Common Lisper. But for those of you who are not familiar with Lisps, then exec basically means, I have a variety of expressions that I want to run each of them sequentially, and then the return value of this expression is just going to be the return value of the last expression. So basically here I'm saying, hey, I am going to calculate this expression form. I'm going to calculate it, and then I'm going to calculate this tuple form, this unit form, and then I will return a unit. That, exec is basically very useful when you want to do side effecting computations sequentially, because you can just do all your side effects, and then at the end you return some value. In this case, unit, because this method expects void. So this is as far as we're gonna go with this anonymous classes. There's really not much more than that. You basically now understand how to make anonymous classes, but this here is more complicated. This here is way more complicated. This is an actual full-blown class definition in Lux. This is the implementation of JVM async, which is the implementation of the promise abstraction for Lux, which I later use in some functions to make things a little bit more comfortable to use. So let's check this out. Let's dissect this. So here, I'm declaring that this class is final. You cannot extend it. And it has one type parameter, A, which is going to be the type parameter of the contents of my async type. And it has no superclass. So again, you could have a superclass here. I omitted it. It has no superclass. And it doesn't have also a list of interfaces. So I am extending object directly. So here I have these three fields, all private, result, which is a boolean, datum, which is an A, it contains my A data, and a waiting list, which is a Java util.list of Lux function. Lux function is a class that not a class, it is currently an interface that is automatically generated by the compiler whenever you compile Lux programs. And I use it, to have a waiting list of functions that I can just invoke, functions that they listen on the async until a value arrives, and then once the value arrives, I call all those functions with that value. Now some of you might think, but wait a moment, why isn't this a list of A to unit, for instance? A list of functions from A to unit. After all, I'm going to be working with functions, and they're going to be listening for this. So it could be like functions like that. Well, remember how I told you previously that in the arguments list of method imports, you cannot refer to arbitrary Lux types, but only to Java types? Well, the same goes for this, and that is why. I cannot have a list of Lux types, I can only have a list of Java types here. It's a little bit annoying, but currently that's the way it works. Maybe in the future I'm gonna be able to figure out how to use Lux types in a way that is more integrative of both sides. But right now you can only use Java types here. So these here are two constructors, both public. And let's dissect this again. We have this tag public, the name of the method, which is just for constructors, it is new. Here goes the list of type variables here, it is empty. The list of arguments, also empty. This tuple here is the same as this tuple here for the object macro. It is a list of arguments to pass to the constructor of the superclass. But since I am extending object and object takes no arguments, then this is empty. And then I have this value, which is the expression that I need to evaluate. Remember, I don't need to add a return type for constructors because it is always the same as the class itself. So this method returns a JVM async. And here you set the values for my result value, my result field, my waiting list field, and datum doesn't get added anything, so it's just null. And finally return unit. Even though this method always returns the object itself, I have to act as if it returned void. So in the end I have to return unit. I know it looks weird, but that's the rule. Now this syntax here looks very weird. Okay, so what is this? Well, in this def class macro, and this is a feature of the def class macro. That's not how it. This code here that you're seeing is not how Lux actually receives class definitions. The real syntax is much more uncomfortable, because the real syntax is meant to be easy to consume by the compiler, not easy to write by users. So that's why. So to make things a little bit easier, the def class macro includes a lot of nice utilities. So for instance, within the body of any method, if you want to refer to any field, you just refer it as dot the name of the field, and that's it. You're done. And if you want to set the value of a field, you just give it this, use this colon equals operator here, then the name of the field, and then finally the value, and that's it. So that's why it looks like this. Now mind you, this isn't the real syntax for accessing fields and setting fields in Lux. The real syntax is actually more complicated to use. However, for the sake of making it easier for people to use this syntax and to define class and stuff like that, the def class macro introduces these kinds of utilities for convenience. And then we have this other constructor. This one does take a value, so we immediately resolve the async, we set the value, and we set the waiting list to null because we're not going to be using it from this point forward, because once we have a value there's no point in waiting. We also have this, you can also see here that we are using methods. We can invoke our own methods here. Here we are invoking our empty constructor using new here. We're invoking this constructor here. Again, just check the syntax, dot, then the name of the method, and finally a bang. Then we give it the arguments. Simple as that. So we have this. We get a new container here. This locking here is like synchronized for in Java. So we're going to be synchronizing on the object itself, which is referred to with underscore JVM underscore this. Hopefully in the future I will come up with a better name, because I will agree this looks kind of ugly, but right now this is this. This is the Java this. Is the way to refer to the object itself within a method. Also, by the way, here's syntax for methods. This here we say it's public. Then the name of the method, then the type variables of the method, which are none. Then the arguments, name of the argument, type of the argument, all within parentheses and within this tuple. And we can have more than one argument if we want. And then the return type. So if it's already resolved, then I don't need to keep resolving it, so resolution is false. Otherwise, I set datum, set the result status, and call every element in the waiting list, then set the waiting list to null, finally return true. Very simple. Here I have this a few other methods, but beyond this, it's pretty. After all we've seen, it's pretty easy to understand what's going on. Oh, and by the way, remember when I told you there were functions for doing translations, like int to long and long to int? Well, this here is a function from the host module. It is int to long, and here we have the opposite, long to int. Because here we know index here is a Lux integer, which is a long in Java, and this list get method requires an actual Java integer, so we transform it from long to integer before we use it. By the way, the module in question for doing host interop is called lux/host. All these interesting macros are there, and a few functions, many more than what we're going to be seeing right now, because it's quite a lot. But you don't need to know everything, because a lot of those things get used in a way, automatically. A lot of the machinery that comes from that module gets used automatically when you do imports and definitions and class definitions, stuff like that. Now here we define our class, and here we are actually importing the class within this module, because the class did not get imported, it just got compiled. Okay, so with this, by doing this import, we actually get to be able to use the methods and make instances of those class of this class in general Lux code. Now, this might look very weird to you, very, very weird, because, why is it that we need to import the class when we already define it? But there are a few reasons for that, and one is, for instance, like, check this out. Here in this class, I have two different constructors. So if I were to immediately automatically import it just from the class definition, when I refer to JVM async : new, to which one am I referring? Am I referring to this constructor or am I referring to this constructor? There's no way of knowing, but if you do an explicit import, yeah, you can know. Now, maybe in the future I will enhance the def class macro so that you can immediately tell it, hey, I want to import everything in here, so it doesn't have to, you don't need to do it explicitly later. Yeah, that's a possibility, but for now, this is the way things are done. And well, the rest of this code is just using that kind of stuff, and there's nothing here that we haven't seen before. So this is a nice primer on JVM interop in Lux. It might look a little bit complicated because the syntax is kind of new, but it's not really that hard. And the idea is that you use these things to bring into your Lux programs the features that you need from the JVM, but that you won't rely on this for common programming. Right, so you're going to be importing this on some module, doing what you need to do, and the rest of your program doesn't have to see that because it's just going to be working with normal Lux types. It's going to be working with normal Lux functions. However, there is one caveat that I need to say. None of the definitions you get when you do JVM import, none of them get exported. So they are all local to the module. Everything that I imported here from the JVM, I can use in the rest of the module, but I can refer to it from other modules that import this Lux concurrency async module. So none of them are imported. The reason is that, if you have, there are two reasons. One is you don't want to end up polluting your imports and your dependencies everywhere by exporting a bunch of stuff that you only wanted to use in one place. And the second is, I don't want to encourage people to rely too much on direct interaction with the JVM. I would rather encourage people to interact with the JVM in one place, then wrap everything in a nice functional interface and a nice functional API and work with that. And by not exporting anything here directly, hopefully people won't get the idea of just exporting this and making their entire programs very reliant on direct details of JVM interop. But if people later on decide, hey, we really, really want this, and they give me a good reason, I could change that. But right now, nothing that you import from the JVM gets exported automatically to the rest of your program. So that's something to take into account. So I also wanted to talk about another bit of information, another feature of the language here, but the video is already a little bit long, and I think that bit of functionality can be left for another day. So for now, we're going to leave this here. So there are not going to be any more videos during the weekend because I'm going to take the weekend off, but back on Monday I'm going to be back with more videos. So see you then.